Hello, this is Connor Bush, and here is my race to the wall circuit with the ultrasonic distance sensor in it, the HCSR04. So this is basically the same as the last race to the wall circuit, except it has a ultrasonic distance sensor within it. So I'm going to actually show you the last one, the race to the wall circuit version 1, which had the touch wire in it. So I'm going to quickly simulate this. So basically what happens is the motors are going to go forward, and once the touch wire is pressed, the motors will turn the opposite way in reverse mode, and the LED will turn on. Now this is the TC or T5000, the color sensor. So once this will be detecting white at the moment, which is in reverse mode, and now that it's in reverse mode, it's in the code. It's going to ask, well, whenever I see a black piece of paper, this switch will flick, the motors will stop, and the LED will flash. So that's basically what it's supposed to do. So it's supposed to drive to the wall. Once it detects the wall, it's going to reverse, and then once it detects a black piece of paper, it will then stop. So that's basically the same as what this is doing, except this has a ultrasonic distance sensor which sends out sound waves, and it will come back. It will bounce out of one, and it will come back into the other, and it will. In my code, I have a little calculation that calculates the distance. Yeah, so I can explain how this works now. So I'm going to simulate this now. Now basically the motors will be going forward, and in my code I have it set to whenever, so it can freely drive. It's going to keep driving forward, the motors, and once it goes, I have it set as below or equal to 20 centimeters. So it's at 20 centimeters now, 20.4, and once I go below that, the LED will turn on, and the motors will spin the opposite direction, which is reverse. And then the same thing again with the color sensor. Once that detects a black piece of paper, the red LED will flash and the motor will stop. So now we'll go into the code. Now I have the same thing as usual. I have my define pins, hashtag define pins, just to allow me to quickly change between, if there is an error, if anything happens, I can swap the pins into a different pin and then simply change the number there. So I have the duration set as a long value, and which is basically a decimal value, and I have an integer set to centimeters, and I have it in inches. Now I don't really use the inches. The only way I just have inches just to help me do my see what I'm getting, what values I'm getting. So I have a serial begin here. It starts at 9,600 bits per second. And now I have my pin mode set to my trig pin, which is the output of the trigger pin is right there, which goes straight up to pin 11. I have that defined there. And then I have the echo pin as an input, and the echo pin is this one here, and it goes straight up to pin number 10. And now I have my VCC connected to 5 volts, and I have my ground connected to the ground here. And it's the same as the last one. I have pin mode, motor A, output. I have all my outputs here, with all the motors. This is all these. I have my motors there, and it's all connected to my H bridge. And the infrared is an input. That is this switch here. The LED is an output. So we'll go into the loop. I have set int state equals to 0. Now there's not much changed here. I have integer black white. I've taken out I think it was input, yeah. I had input here in the last circuit, but now I've taken that out and I've changed it just to the trig pin, which is going to push out a low or a high wave, a sound wave, and it's just going to repeatedly go low, high, low, and it will just keep going on like that. The black white is digital read of the infrared, so that's for state 2. So I have a duration here. It's pulse in. It reads the pulse of the echo pin. Basically, it just stays on high. And then here's my calculations. Now I've gotten these online. I have centimeters is equal to duration multiplied by 0.0343 and it's divided by 2. And that will allow me to see in my serial monitor. It's not on now. That will let me see in my serial monitor the centimeters in each bit. And then in inches the same thing. So the loop is going to start off here. So it's going to say if the state is equal to 0, which it will be at the very start, which is, oh sorry, I reset all that, which is right now as the motors are just going forward and the LED isn't on. It's going to just, it says it here, it's just going to go forward. And then I have if, in that loop I have if centimeter is less than or equal to 20 centimeters. So that's this thing here. So this is going to be, it's just going to be, so basically the object will be here and it will slowly be driving towards it. And in my code there it says less than or equal to 20. So once it goes below 20, there, it will go straight into state equals 1. And in state equals 1, it's in reverse mode, which it has gone into reverse mode. And the LED is on, that's in the reverse void. And now it's in a sentence where it says black white. If black white is equal to 1, then state is equal to 2. So at the moment, the black white is equal to 0. And then as soon as I flick this, now it's in state 2. So in state 2 it says stop. So the motors are stopped, the LED is flashed, and then I have all my voids here just to explain that. So in my void stop there it says all the motors are low, which basically means don't move. And the red LED is high for 300 milliseconds, and then low for 300 milliseconds.